Self-exercise 2.8, questions 1. Find the equations of tangent and normal to the following curve at the given point. Using this diagram as example, then the L1 here will represent the tangent and the L2 here will be the normal, and this point here will be the given point. To find the gradient tangent, first we need to find the first derivative. This will equal to 10x minus 7. To find the gradient tangent, substitute the x-coordinate of the points into the first derivative. Then the gradient tangent will be 10 minus 7, which is 3. To find the equation of tangent, then we can use this formula. Here, the x1, y1 will be the given point, which is one of the points on the tangent. Then we're going to get y minus negative 3 equal to m, which is the gradient tangent, x minus 1. So y plus 3 equal to 3x minus 3. Then y is equal to 3x minus 3 minus 3. Then the equation will be y equal to 3x minus 6. Normal is perpendicular to tangent. Therefore, when the gradient of normal multiplied the gradient of tangent, this is equal to negative 1. Then the gradient of the normal will be negative 1 over 3. Using the same formula, then the equations of normal will be y minus negative 3 equal to negative 1 over 3 x minus 1. Then y plus 3 equal to negative 1 over 3x plus 1 over 3. Then y equal to negative 1 over 3x plus 1 over 3 minus 3. Then the equations will be y equal to negative 1 over 3x minus 8 over 3. Questions B. First, find the first derivative. This is equal to 3x squared minus 5. To find the gradient tangent, substitute the x-coordinates of the given points into the first derivative. This is equal to 12 minus 5, which is 7. To find the equation of tangent using this formula and the given point as x1 and y1, then we will get y minus 4 equal to 7 x minus 2. Then y equal to 7x minus 14 plus 4. Then the equation will be y equal to 7x minus 10. Next, when the gradient of normal multiply the gradient of tangent, which is 7, this is equal to negative 1. Then the gradient of normal is negative 1 over 7. Then the equations of normal will be y minus 4 equal to negative 1 over 7 x minus 2. Then y is equal to negative 1 over 7x plus 2 over 7 plus 4. Then the equation will be y equal to negative 1 over 7x plus 30 over 7. Question C. So first, we can write these functions f of x equal to 2x plus 1 to the power of 1 over 2. Then, the first derivative will be 1 over 2 brackets 2x plus 1 to the power of negative 1 over 2. Then, differentiate the terms in the bracket, which is 2. So, simplify the 2 here. Then, the first derivative will be 1 over 2x plus 1 to the power of 1 over 2. Or you can write this as square root 2x plus 1. To find the gradient of tangent, substitute the x-coordinate of the given point, which is 4, into the first derivative. This is equal to 1 over 3. So here, let's the given points as x1 and y1. Then the equation will be y minus 3 equal to 1 over 3 x minus 4. Then y equal to 1 over 3x minus 4 over 3 plus 3. Then the equation will be y equal to 1 over 3x plus 5 over 3. Next, when the gradient of normal multiply the gradient of tangent, the answer is equal to negative 1. Then the gradient of normal is negative 3. Using the same formula, the equation will be y minus 3 equal to negative 3x minus 4. Then y equal to negative 3x plus 12 plus 3. Then y equal to negative 3x plus 15. Question D. To find the first derivative, here we need to use the quotient rule. First, copy the v, x minus 1, then differentiate the u, which is 1. Then minus, copy the u, x plus 1, then differentiate the v, which is 1, over v square, x minus 1 square. Expand for the numerator, then we're going to get x minus 1 minus x minus 1. So x minus x will be cancelled. Then this is equal to negative 2 over x minus 1 square. To find the gradient of tangent, substitute the x coordinate of the given points into the x here. This is equal to negative 2 over 4, which is negative 1 over 2. Then using this formula to find the equations of tangent, and the given point will be the x1, y1. This will be y minus 2 equal to negative 1 over 2, x minus 3. Then y equal to negative 1 over 2x plus 3 over 2 plus 2. Then the equation will be y equal to negative 1 over 2x plus 7 over 2. Then, when the gradient of normal multiply the gradient of the tangent, this is equal to negative 1. Then the gradient of normal is equal to positive 2. Then it will be y minus 2 equal to 2x minus 3. Then y equal to 2x minus 6 plus 2. Then the equation will be y equal to 2x minus 4. Questions number 2. Find the equations of the tangent and normal to the following curve at the given value of x. So to find the equations of tangent and normal, we will need its gradients and one coordinates of the points on the tangent and normal. For questions A, the x equal to 1 will be the x coordinates of that points. To find the coordinate of y, then substitute x equal to 1 into the equations. Then y is equal to 1. Then the coordinate will be 1, 1. Next, we're going to find the first derivative, dy dx. It will be 6x squared minus 4. To find the gradient of tangent, substitute the x coordinates into the dy dx. Then 6 minus 4 is 2. This will be the gradient of tangent. To find the equation of tangent, we're going to let the coordinate of the points 1, 1 as x1, y1. Then using this formula, y minus 1 equal to 2x minus 1. Then y equal to 2x minus 2 plus 1. Then y equal to 2x minus 1. Next, we're going to find the gradient of normal. As normal is perpendicular to tangent, so when the gradient of normal multiply the gradient of tangent, this is equal to negative 1. Then the gradient of normal will be negative 1 over 2. So using the same formula and the same coordinates, the equations of normal will be y minus 1 equal to negative 1 over 2, x minus 1. Then y equal to negative 1 over 2x plus 1 over 2 plus 1. Then y equal to negative 1 over 2x plus 3 over 2. Questions B. To find the coordinates of the points, Substitute x equal to 4 into the equations. This is equal to 2 minus 1 over 2, which is 3 over 2. Then the coordinates will be 4, 3 over 2. To find the first derivative dy dx, I'm going to write the equations as y equal to x to the power of 1 over 2 minus x to the power of negative 1 over 2. dy dx is equal to 1 over 2x to the power of negative 1 over 2 plus 1 over 2x to the power of negative 3 over 2. This is equal to 1 over 2x to the power of 1 over 2 plus 1 over 2x to the power of 3 over 2. X to the power of 1 over 2, I can write this as square root of x. And for x to the power of 3 over 2, I can write this as square root of x to the power of 3. To find the gradient of tangent, substitute x equal to 4 into the dy dx. This is equal to 1 over 4 plus 1 over 16, which is equal to 5 over 16. This will be the gradient of tangent. So here let's the coordinates of the point as x1, y1. Then the equations will be y minus 3 over 2 equal to 5 over 16 x minus 4. Then y equal to 5 over 16x minus 5 over 4 plus 3 over 2. Then the equation is y equal to 5 over 16x plus 1 over 4. Next, we're going to find the gradient of normal. So gradient of normal multiply the gradient of tangent. This is equal to negative 1. Then the gradient of normal is negative 16 over 5. Then the gradient of normal is y minus 3 over 2 equal to negative 16 over 5 x minus 4. Then y equal to negative 16 over 5x plus 64 over 5 plus 3 over 2. Then y equal to negative 16 over 5x plus 143 over 10. Question C. To find the coordinates of the point, substitute x equal to 3 into the equations. Then y equal to the square root of 4, which is 2. Then the coordinates will be 3, 2. To find the dy dx, I'm going to write the equations as y equal to bracket x plus 1 to the power of 1 over 2. Then dy dx is equal to 1 over 2 bracket x plus 1 to the power of negative 1 over 2. Then differentiate the terms in the bracket, which is 1. This is equal to 1 over 2 x plus 1 to the power of 1 over 2. For this part, I can write this as square root x plus 1. To find the gradient of tangent, substitute the x coordinate 3 into the dy dx. Then the answer is equal to 1 over 4. So here let's the coordinates as x1, y1. Then the equations of tangent will be y minus 2 equal to 1 over 4 x minus 3. Then y equal to 1 over 4x minus 3 over 4 plus 2. Then the equations will be y equal to 1 over 4x plus 5 over 4. Next, when the gradient of normal multiply the gradient of tangent, this is equal to negative 1. Then the gradient of normal is negative 4. Then the gradient of normal will be y minus 2 equal to negative 4 x minus 3. Then y equal to negative 4x plus 12 plus 2. Then the equation is y equal to negative 4x plus 14. Questions D. To find the coordinates of the point, substitute x equal to negative 2 into the equations. This is equal to 5 over 5, which is 1. Then the coordinate will be negative 2, 1. To find the dy dx, I'm going to write the equation as y equal to 5 brackets x squared plus 1 to the power of negative 1. dy dx is equal to negative 5 brackets x squared plus 1 to the power of negative 2. Then differentiate the terms in the bracket, which is going to be 2x. This is equal to negative 10x over x squared plus 1 to the power of 2. To find the gradient of tangent, substitute x equal to negative 2 into the dy dx. This is equal to negative 20 over 25, which is equal to 4 over 5. To find the equation of tangent, let the coordinates as x1, y1. Then the equations will be y minus 1 equal to 4 over 5, x minus negative 2. Y equal to 4 over 5x plus 8 over 5 plus 1. Then the equation is y equal to 4 over 5x plus 13 over 5. Next, when the gradient of normal multiply the gradient of tangent, this is equal to negative 1. Then the gradient normal is negative 5 over 4. Then the equations will be y minus 1 equal to negative 5 over 4, x minus negative 2. Then y equal to negative 5 over 4x minus 5 over 2 plus 1. Then y equal to negative 5 over 4x minus 3 over 2. Questions E. To find the coordinates of y, substitute x equal to negative 1 into the equations. This is equal to 2 minus 1, which is 1. Then the coordinates will be negative 1, 1. To find the dy dx, I'm going to write the equations as y equal to 2 plus x to the power of negative 1. Then dy dx is negative x to the power of negative 2. This is equal to negative 1 over x squared. To find the gradient of tangent, substitute x equal to negative 1 into the dy dx. Then this is equal to negative 1. So here let's the coordinate as x1, y1. Then the equations will be y minus 1 equal to negative 1, x minus negative 1. Then y equal to negative x minus 1 plus 1. Then equation will be y equal to negative x. Next, to find gradient of normal, when it's multiplied with the gradient of tangent, negative 1, the answer will be negative 1. Then the gradient of normal will be positive 1. Then the equations of normal will be y minus 1 equal to 1, x minus negative 1. Then y equal to x plus 1 plus 1. Then the equation is y equal to x plus 2. Questions F. To find the coordinate, substitute x equal to 3 into the equations. This is equal to 12 over 4, which is 3. Then the coordinates will be 3, 3. To find the dy dx, here we need to use the quotient rule. So this will be the u and v. First, copy the v, x plus 1. Then differentiate the u, which is 2x, minus copy the u, x squared plus 3. Then differentiate the v, which is 1, over v square, which is x plus 1 square. Solve the numerator, we're going to get 2x squared plus 2x minus x squared minus 3. Then we're going to get x squared plus 2x minus 3. To find the gradient of tangent, substitute the x coordinate of the point, which is 3, into the dy dx. This is equal to 12 over 16, which is 3 over 4. So here, let's the coordinates of the point as x1, y1. Then the equations will be y minus 3 equal to 3 over 4, x minus 3. Then y equal to 3 over 4x minus 9 over 4 plus 3. Then y equal to 3 over 4x plus 3 over 4. Next, to find the gradient of normal, multiply it with the gradient of tangent, 3 over 4, the answer will be negative 1. Then gradient of normal will be negative 4 over 3. Then the equations will be y minus 3 equal to negative 4 over 3, x minus 3. Y equal to negative 4 over 3x plus 4 plus 3. Then y equal to negative 4 over 3x plus 7. Question number 3. A tangent and a normal is drawn to the curve y equal to x square root 1 minus 2x at x equal to negative 4. Finds a the value of dy dx at x equal to negative 4. So first, I got to write the equation as y equal to x bracket 1 minus 2x to the power of 1 over 2. So here, using the product rule, this will be the u and v. Then dy dx will be, first copy the u, x, then differentiates the v. This will be 1 over 2 bracket 1 minus 2x to the power of negative 1 over 2. Then differentiate the terms in the bracket, which is negative 2, plus copy the v, then differentiates the u, which is 1. So here we can cancel for the 2. Then this is equal to negative x over 1 minus 2x to the power of 1 over 2, which I can also write this as square root 1 minus 2x plus square root 1 minus 2x. To find the value, substitute x equal to negative 4 into the x in the dy dx. This is equal to 4 over 3 plus 3. Then the answer will be 13 over 3. Questions B. Finds the equations of the tangent. Here, the value 13 over 3 will be the gradient of tangent at x equal to negative 4. To find the y coordinates of the points, substitute x equal to negative 4 into the equations of the curve. This is equal to negative 4 times 3, which is negative 12. Then the coordinates will be negative 4, negative 12. So let this coordinate as the x1, y1. Then the equations of tangent will be y minus negative 2 equal to 13 over 3, x minus negative 4. This is equal to y plus 12 equal to 13 over 3, x plus 4. Then y equal to 13 over 3x plus 52 over 3 minus 12. Then y equal to 13 over 3x plus 16 over 3. Question C. Finds the equations of the normal. So from the previous questions, we know that the gradient of tangent is equal to 13 over 3. And the coordinates of the point is negative 4, negative 12. So when the gradient of normal multiplied with the gradient of tangent 13 over 3, the answer is negative 1. Then the gradient of normal is negative 3 over 13. Then the equations will be y minus negative 12 equal to negative 3 over 13, x minus negative 4. This will be y plus 12 equal to negative 3 over 13, x plus 4. Then y equal to negative 3 over 13x minus 12 over 13 minus 12. This is equal to y equal to negative 3 over 13x minus 168 over 13. Question number 4a. The tangent to the curve y equal to bracket x minus 2 square at the point 31 passes through k7. Finds the value of k. If we expand these equations, we're going to get y equal to x squared minus 4x plus 4, which is a quadratic equation. Let's say this curve here represents these equations. And here will be the point 31. Then these straight lines here will be the tangent to the curve at the point 31. This tangent also passes through the points K7. So let's say here will be the points K7. So with the informations given, first we can find the gradient of the tangent. dy dx is equal to 2x minus 4. To find the gradient of tangent at the point 31, substitute the x coordinate, which is 3, into the dy dx. Then 6 minus 4 is equal to 2. The tangent is a straight line. Therefore, its gradient will be the same at any points on the tangent. So, if we find the gradients of the tangent using the coordinates of these 2 points, the answer will be 2. So, using this formula, 7 minus 1 over k minus 3, the answer is 2. Then, 6 is equal to 2k minus 6. Then, 2k is equal to 6 plus 6, which is 12. Then k is equal to 12 divided by 2, which is 6. Questions 4b. The normal to the curve y equal to 7x minus 6 over x at x equal to 1 intersects the x-axis at a. Finds the coordinate of a. So let us assume this is the curve and this is the x-axis. And let's say here is x equal to 1. Then the points x equal to 1 will be here on the curve. Then this will be the tangent line at x equal to 1. Then this will be the normal. So the point A will be the intersection point between the x-axis and the normal, which is here. So first we can find the dy dx. Then I'm going to write the equations of the curve as y equal to 7x minus 6x to the power of negative 1. Then dy dx is 7 plus 6x to the power of negative 2, which I can write as 7 plus 6 over x squared. To find the gradient of tangent, substitute x equal to 1 into the dy dx. Then 7 plus 6, this is 13. Then next we can find the gradient of normal. So when gradient of normal multiply the gradient of tangent, which is 13, the answer is negative 1. Then the gradient of normal is negative 1 over 13. To find the equations of normal, we need to find the coordinate of this point. To find its coordinate, substitute x equal to 1 into the equations of the curve. This is equal to 7 minus 6, which is 1. Then the coordinates will be 1, 1. So here let's the coordinate as x1, y1. Then the equations of normal will be y minus 1 equal to negative 1 over 13, x minus 1. Then y equal to negative 1 over 13x plus 1 over 13 plus 1. Then the equations will be y equal to negative 1 over 13x plus 14 over 13. Point A is the x-intercept. Therefore, the coordinate y is equal to 0. To find the coordinate A, substitute y equal to 0 into the equations of normal. Then 1 over 13x equal to 14 over 13. So here I can multiply both sides with 13. So the 13 here will be cancelled. Therefore, x equal to 14. Then the coordinates of the points A will be 14, 0.